The darkness above us hides the most terrifying truth science has ever uncovered. Right now, as you watch this video, our entire galaxy is racing toward complete and utter destruction at over 250,000 miles per hour. Scientists have just made a discovery so shocking that it's rewriting everything we thought we knew about our cosmic fate. The Milky Way, our home, our sanctuary, the birthplace of every human who has ever lived, is about to be completely annihilated, and the countdown has already begun. If this revelation sends chills down your spine, hit that subscribe button and let me know in the comments. Are you ready to face the ultimate truth about our galaxy's terrifying destiny? The evidence is so overwhelming that even the most optimistic astronomers can no longer deny what's coming. But before we dive into this cosmic nightmare, I need you to prepare yourself for discoveries that will fundamentally change how you see our place in the universe. Because what's approaching us from the depths of space is so massive, so violent, and so inevitable that it makes every disaster movie look like a children's fairy tale. The year 2024 marked a turning point in astronomical research, when teams of scientists using the most advanced space telescopes ever built began to uncover the horrifying reality of our galaxy's fate. The Hubble Space Telescope, working in conjunction with the European Space Agency's Gaia mission, has been tracking the movements of our neighboring galaxy Andromeda with unprecedented precision. What they discovered defied all previous calculations and sent shockwaves through the scientific community. The Andromeda Galaxy, containing over 1 trillion stars, more than 3 times the number in our own Milky Way, is hurling directly toward us at a speed that makes bullet trains look stationary. This isn't just another astronomical curiosity that affects some distant corner of the universe. This is a direct threat to every single star, planet, and form of life in our galaxy, including Earth itself. The collision between these two galactic titans was once thought to be a distant concern, something that might happen in the far future, giving humanity countless generations to prepare or evolve beyond Earth. However, recent research published in 2024 and early 2025 has dramatically altered this timeline. Advanced computer simulations running hundreds of thousands of different scenarios have revealed that the probability of a catastrophic collision is much higher than previously calculated, where astronomers once gave us a comfortable buffer of uncertainty, suggesting that the galaxies might simply pass by each other in a cosmic near-miss. The latest data tells a far more terrifying story. The gravitational dance between our galaxy and Andromeda has been precisely mapped, and the results are undeniable. We are locked in a death spiral from which there is no escape. Dr. Roland van der Marel, one of the leading researchers at the Space Telescope Science Institute, has spent years analyzing the trajectory data, and his conclusions are chilling. The Andromeda Galaxy isn't just approaching us randomly, it's being pulled toward us by the same gravitational forces that keep our solar system intact, but on a scale so massive that it defies human comprehension. Every second that passes, Andromeda draws approximately 70 miles closer to our galaxy. That might not sound like much when dealing with the vast distances of space, but when you multiply that by the number of seconds in a day, then days in a year, the approaching catastrophe becomes terrifyingly real. In just 1 year, Andromeda closes the gap by more than 2 billion miles, and this relentless approach has been continuing for billions of years. What makes this discovery even more shocking is the revelation that our galaxy isn't just facing a single threat. Recent observations have identified that the collision with Andromeda is part of a much larger cosmic catastrophe involving multiple galaxies in our local group. The Triangulum Galaxy, the third largest galaxy in our cosmic neighborhood, is also being drawn into this gravitational maelstrom, creating a 3-way collision scenario that astronomers are calling the ultimate galactic apocalypse. When these massive structures finally meet, the resulting chaos will reshape space itself, creating gravitational waves so powerful that they will ripple across the entire observable universe. The energy released during this collision will be equivalent to trillions upon trillions of nuclear explosions, occurring simultaneously across millions of light years of space. The timeline for this cosmic destruction has been calculated with disturbing precision. While earlier estimates suggested we had approximately 4 to 5 billion years before the collision, new research published in the journal Nature Astronomy in late 2024 indicates that the merger could begin much sooner than expected. The gravitational influences of nearby galaxy clusters, previously overlooked in collision models, are accelerating the approach of both galaxies. Dr. Till Sawala from the University of Helsinki, who led one of the most comprehensive studies on galaxy collision dynamics, explains that when you factor in the gravitational pull of the entire local group of galaxies, the probability of collision increases to nearly 50% within the next 10 billion years, with some scenarios showing merger events beginning as early as 3.5 billion years from now. But the true horror lies not just in the collision itself, but in what scientists have discovered about the destructive forces that will be unleashed long before the galaxies actually make contact. As Andromeda approaches, its gravitational field will begin to distort the structure of our Milky Way, pulling stars from their stable orbits and hurling them into the cold darkness of intergalactic space. Entire star systems, potentially including billions of planets that might harbor life, will be ejected from our galaxy like cosmic debris from a catastrophic accident. The delicate spiral arms of our galaxy, which have maintained their beautiful structure for billions of years, will be stretched and torn apart by gravitational forces beyond anything our solar system has ever experienced. The supermassive black hole at the center of our galaxy, known as Sagittarius A*, will begin to interact with Andromeda's even larger central black hole, creating a gravitational tug-of-war that will send shockwaves throughout both galaxies. This cosmic battle between two of the most powerful objects in the universe will generate energy on a scale that makes the most violent stellar explosions look like gentle fireflies. Stars that have burned steadily for billions of years will be disrupted from their nuclear fusion processes, causing them to either explode as supernova or collapse into black holes themselves. The night sky that has inspired humanity for thousands of years will become unrecognizable, as familiar constellations are scattered to the cosmic winds and new, chaotic star formations begin to emerge from the gravitational chaos. Recent discoveries have revealed an even more sinister aspect of galactic destruction that scientists never anticipated. Using the James Webb Space Telescope, astronomers have been studying galaxies that are currently undergoing merger events, providing us with a terrifying preview of our own fate. These observations have uncovered evidence that supermassive black holes don't just passively participate in galactic collisions. They actively accelerate the destruction process by feeding on the chaos around them. As galaxies merge, the black holes at their centers consume vast amounts of stellar material, growing larger and more powerful with each passing moment. This feeding frenzy creates jets of high-energy radiation that sterilize entire regions of space, making it impossible for new stars to form and essentially starving the galaxy to death from within. Dr. Roberto Maiolino from the University of Cambridge, who has been studying these galactic death throes using the Webb telescope, describes the process as cosmic cannibalism on an unimaginable scale. The black holes become so active during merger events that they emit radiation equivalent to billions of stars, creating a phenomenon known as a quasar that can be seen from across the entire observable universe. This isn't just a spectacular light show. It's a death certificate for any life that might exist within the affected regions. The intense radiation strips away the atmospheres of planets, boils away oceans, and renders entire solar systems uninhabitable. What's particularly terrifying is that this sterilization process begins millions of years before the actual galactic collision, meaning that civilizations might be destroyed by the approaching catastrophe long before they even realize what's happening. The destruction doesn't stop with individual star systems. The James Webb Telescope has revealed that during galactic mergers, the very fabric of space-time becomes distorted by the massive gravitational fields involved. This creates regions where the normal laws of physics begin to break down, where time itself moves differently, and where matter behaves in ways that defy our understanding of reality. Planets can be stretched and compressed by tidal forces so powerful that solid rock flows like water, and the fundamental particles that make up all matter begin to decay at accelerated rates. It's a level of destruction so complete that it doesn't just end life, it erases the very possibility of life ever existing again in those regions of space. But perhaps the most shocking discovery of all came in December 2024, when astronomers detected something that shouldn't exist according to all our current models of galactic structure. Using advanced gravitational wave detectors, scientists identified a binary star system orbiting perilously close to our galaxy's central supermassive black hole, Sagittarius A*. This discovery, designated as the D9 system, consists of two stars, locked in a death dance around each other while simultaneously being pulled toward the black hole that anchors our entire galaxy. What makes this discovery so terrifying is that these stars are relatively young, only 2.7 million years old, which means they formed after our galaxy should have become gravitationally stable. The implications of this discovery are staggering. If young stars are still forming in the immediate vicinity of our galaxy's most destructive force, it suggests that the gravitational environment of the Milky Way is far more chaotic and unstable than we ever imagined. Dr. Florian Peisker from the University of Cologne, who led the research team that made this discovery, explains that finding these stars is like discovering that someone is building a house on top of an active volcano. It indicates that our galaxy is already in a state of unprecedented gravitational turmoil, possibly triggered by the approaching influence of Andromeda's massive gravitational field. The D9 system serves as a cosmic canary in a coal mine, warning use that the destruction of our galaxy may have already begun at its very heart. As these stars continue their deadly orbit, they're gradually losing energy and spiraling closer to the supermassive black hole that will eventually consume them. When this happens, the resulting explosion of gravitational waves will ripple outward from the galactic center, potentially destabilizing other star systems and accelerating the overall collapse of our galaxy's structure. It's a cascade effect that could trigger premature stellar explosions and black hole formations throughout the Milky Way, making the eventual collision with Andromeda even more catastrophic than previously calculated. The process of galactic destruction unfolds in stages that are as beautiful as they are terrifying. Computer simulations created by teams at Harvard University and the Max Planck Institute have mapped out exactly how our galaxy will die, using the most powerful supercomputers on Earth to model every gravitational interaction between trillions of stars. These simulations reveal that the merger will begin not with a violent crash, but with a slow, graceful dance that will last for over 1 billion years. The outer edges of both galaxies will begin to interact first as the gravitational fields start to pull at the loosely bound stars in each galaxy's halo region. During this initial phase, millions of stars will be flung out into the empty space between galaxies, creating vast streams of stellar refugees that will drift through the cosmic void for eternity. These ejected stars, along with any planets that might orbit them, will become cosmic orphans, forever separated from the warmth and gravitational stability of their parent galaxies. The night sky from any planets in these systems will be almost completely dark, with only the faint glow of distant galaxy clusters providing any light in an otherwise empty universe. It's a fate that some scientists describe as worse than destruction: eternal isolation in the cold, empty darkness of intergalactic space. As the merger progresses, the gravitational chaos will intensify dramatically. The spiral arms of both galaxies will be stretched and distorted, creating massive tidal streams of stars and gas that stretch across hundreds of thousands of light years. These streams will glow with the light of newly formed stars, created when gas clouds collide and compress under the extreme gravitational forces. But this burst of star formation will be short-lived, as the same forces that create these new stars will also tear apart the molecular clouds needed for future star birth. The result is a final, spectacular fireworks display before our galaxy's ability to create new life comes to an end forever. The climax of this cosmic catastrophe will occur when the supermassive black holes at the centers of both galaxies finally meet. This event, which astronomers have nicknamed the ultimate cosmic collision, will be the most energetic event in the local universe since the Big Bang itself. The two black holes, one containing 4 million times the mass of our Sun, and the other containing over 100 million solar masses, will spiral around each other in an increasingly tight orbit, generating gravitational waves so powerful that they will literally shake the fabric of space-time itself. These waves will travel outward at the speed of light, creating ripples in reality that will be detectable by civilizations in distant galaxies, billions of light years away. When the black holes finally merge, they will create a single supermassive black hole containing the combined mass of both previous objects, plus an additional amount equal to several million suns worth of pure energy that will be radiated away as gravitational waves. This new black hole will be so massive and so energetic that it will likely be ejected from the center of the newly formed galaxy by the recoil from its own gravitational wave emissions. Imagine a black hole containing more than 100 million times the mass of our Sun being literally kicked out of its galaxy like a cosmic soccer ball, carrying with it the gravitational anchor that holds billions of stars in stable orbits. The galaxy that emerges from this cosmic collision will be nothing like the beautiful spiral structure we call home today. Computer models predict that the merger will create a massive elliptical galaxy, which scientists have already named Milkomeda, that will contain all the stars from both parent galaxies but in a completely different configuration. Instead of the elegant spiral arms that have defined our galaxy for billions of years, Milkomeda will be a roughly spherical blob of randomly distributed stars with no discernible structure or organization. The new galaxy will be larger than either of its parents, but also much more diffuse, with vast regions of empty space between scattered star systems. For any civilizations that manage to survive the merger process, life in Milkomeda will be radically different from anything we can imagine today. The night sky will be incredibly bright, filled with billions of stars that are much closer together than in our current galaxy. However, this apparent abundance of light will be deceptive, as the gravitational chaos of the merger will have disrupted the formation of new planetary systems for billions of years. The interstellar medium, the gas and dust between stars that serves as the raw material for planet formation, will have been heated to such high temperatures by the merger process that it will be unable to cool down and condense into new worlds for eons to come. The question that haunts every astronomer studying this cosmic catastrophe is whether Earth and our solar system will survive the galactic merger. The answer is both reassuring and terrifying in equal measure. The good news is that the distances between stars are so vast that the probability of our Sun directly colliding with another star during the merger is extremely small, less than 1 in a billion. However, this statistical comfort is cold consolation when you consider the other ways that our solar system could be destroyed or severely disrupted during the galactic collision. The most likely scenario for Earth's fate involves our entire solar system being ejected from the galaxy during the merger process. Gravitational interactions between passing stars could disrupt the Sun's orbit around the galactic center, sending our entire stellar neighborhood flying off into intergalactic space. While this might sound like a form of cosmic salvation, escaping the chaos of the merger by fleeing to the safety of empty space, the reality is far more grim. Once ejected from the galaxy, our solar system will become permanently isolated from any other star systems, doomed to drift alone through the cosmic void for the rest of eternity, even if our solar system manages to remain within the boundaries of the newly formed Milkomeda galaxy. The Sun itself faces a more immediate threat than galactic merger. Long before the collision with Andromeda reaches its climax, our star will begin the natural aging process that affects all stars of its size and mass. In approximately 5 billion years, coincidentally, almost exactly the same time frame as the galactic collision, the Sun will begin to evolve into a red giant star, expanding to hundreds of times its current size and likely engulfing the inner planets, including Earth. This cosmic timing is not mere coincidence, but represents one of the most profound ironies in astronomy. Humanity and all life on Earth are caught between two cosmic clocks, both counting down to inevitable destruction on almost exactly the same timeline. Whether our planet is consumed by our expanding sun or flung into the darkness of intergalactic space by the galactic merger, the outcome for Earth-based life appears to be sealed by the fundamental laws of physics and stellar evolution. However, some scientists argue that the galactic collision might actually provide opportunities for life to survive and even thrive in ways that wouldn't be possible in our current cosmic environment. Dr. Avi Loeb from Harvard University has proposed that the increased stellar density in the merged galaxy could create more opportunities for interstellar travel and communication between different star systems. The reduced distances between stars and Milkometa might make it possible for advanced civilizations to spread from one stellar system to another, creating a galactic network of life that could survive the death of individual stars or planetary systems. This optimistic scenario assumes, of course, that technological civilizations can develop the capability to travel between star systems and establish self-sustaining colonies on multiple worlds. For humanity, this will require advances in space, propulsion, life support systems, and terraforming technology that are currently beyond our wildest dreams. We would need to master the ability to travel distances of tens or hundreds of light years, establish permanent settlements on planets orbiting other stars, and maintain communication and trade networks across interstellar distances. The timeline for achieving such technological capabilities becomes crucial when measured against the countdown to galactic destruction. If humanity continues to advance at our current rate of technological progress, we might develop primitive interstellar travel capabilities within the next few centuries. However, creating the kind of robust, multi-system civilization that could survive galactic merger would likely require thousands or tens of thousands of years of continued technological development and social evolution. This raises profound questions about humanity's long-term survival strategy.